Welcome everyone, welcome again. This time I will present you, because I have found it just accidentally, what is the combination of constraints, grounded statuses and interfaces between components when flexible subassembly can be used and when top-level assembly becomes stable. It is very surprising to find out what is needed. It is also not logical, inconsistent with the overall logic of Inventor, so I believe it's a bug, and I am making this video to show you how to reproduce it and so you could find the cause and remove it finally from the software. So I will present you few scenarios and I will show you how these things behave. So this is the assembly that you may have remembered from the previous video. So we have this red element and this element that is a flexible subassembly that is used as a handle. I will now not explain how this is constrained. You can examine it. It only has degrees of freedom left that are needed on the top level, and on the top level these constraints here are applied in such a way so there is no degree of freedom left now unconstrained. So we will go through 4 scenarios for this assembly. We will start with the attempt number 1 when I unground the flexible subassembly, constrain top-level components in the top-level assembly, and I will constrain components in flexible subassembly to the subassembly. Overall, we have not over and not under constrained case of the assembly. We have just enough number of constraints to reduce all degrees of freedom, and we do not have redundant constraints. So having said that, unground flexible subassembly. So the flexible subassembly, I will call it container subassembly as Johnson, it is ungrounded now. So the top level components are constrained. So this component has constraints that fix its position in regard to the top level assembly origin plane. So this component has no degrees of freedom. And constrained components in the flexible subassembly. So if we examine the flexible subassembly, we'll see that these components are constrained to the flexible subassembly container in such a way that their position is fully defined and only those degrees of freedom are left that are needed. In case of this, we can quickly go through. So this is a rotation of the central shaft. Translation of this piece, because it is traveling on shaft, it has a constraint, it has a translation rotation constraint applies, so it moves along according to the thread pitch. This bearing here rotates and slides as it is a free support bearing, and the other side bearing only rotates because it is fixed side bearing. So these are only the degrees of freedom that are left here, and we have, as said, constrained components in the flexible subassembly. This assembly is placed here and it is constrained to the red component, the beam, according to its degrees of freedom. So bearings are constrained to the bearing holes, and there are angle constraints that fix. The first angle constraint is the indicator angle constraint that fixes the angle of this, so it is traveling only this direction, it is not move, because there will be a casing that will fix this angle. And I have also the angle handle angle defined that I will use to drive the assembly. So the idea is to use this drive drive of this constraint as an indication whether constraint solver is capable of solving this assembly or not. Because if I invoke drive for this constraint, the constraint solver is forced to solve the assembly in many positions, and if it fails, then it means that the assembly is not stable. If it doesn't fail, then we have a situation when the assembly can be considered stable, as the constraint solver is capable of solving the assembly in almost any case. So I will now, having set up attempt number 1, that is properly constrained in terms of logic of the constraining, I will try to drive the constraint now. As you can see, we instantly are getting a constraint solver error that tells us it is not possible to solve the assembly near some point. So basically it is ridiculous, because this constraint can be edited, and I can change the value to, I cannot change the value, okay, so generally the constraint solver is not capable of solving the assembly that is constrained properly. So maybe another way of constraining this assembly is more adequate to using flexible components. There are various suggestions, so we will now take to attempt number 2. In the attempt number 2, I will ground the flexible subassembly. This is according to the Johnson's suggestion that flexible subcomponents should be grounded. I do not agree with that, but I will follow that. I will leave the top level components constrained to the top level assembly, and I will unconstrain the flexible subassembly components, so to have the components free to move within the container subassembly, the container flexible subassembly. So overall, we have not over and not under constrained environment once we apply this solution. So again, it should be fully properly constrained assembly, and constraint solver should be able to solve that. There are suggestions that it is better this way. So let's first, before we ground the top level, the subassembly component, and then we will get ourselves into the conflict with the internal constraints. First, I will unconstrain the components. So I will suppress the constraints connecting the flexible subassembly components to the subassembly itself, so to the container assembly. I will save that to be sure. I will now update the environment, and now I need to ground the flexible subassembly container. So now I have grounded flexible subassembly container. I have grounded. I have constrained top level components. I have constrained top level components, because these constraints to the origin planes of the red beam are now active. And I have unconstrained components in the flexible subassembly. Well, I have unconstrained flexible components in the flexible subassembly, so they are free to fly around the flexible subassembly. So now, in such circumstances, according to the Johnson suggestion, it should be possible to drive the constraint now. So as we can see, it is not possible to drive the constraint. The constraint solver gives us an error instantly. So I will cancel that. I will check if it is possible to update the this constraint. So now it is possible to update it to whatever value I need, but it is not possible to drive it. And driving this constraint is key to being able to move this indicator. So if I want to drive it, it fails. So the conclusion is that in this case the assembly is not being solved stably, because driving this constraint is not possible because the constraint solver is not capable of solving the assembly in some points. Although it is ridiculous because it should, because I can apply any number here. So it should be possible to drive the assembly, but it is not. I believe it is a problem with the data preparation for the constraint solver. So the constraint solver gets data that he cannot use for solution because something is messed up. So having attempt number 2 and having proven this is not working, although it seems working, but this is not working. Sorry for that. Oh, okay, so having finished with attempt number 2, we have the solution according to suggestions that is proven not to be fully functional. Now I will get to the attempt number 3. In this attempt, I will force the assembly into over-constrained situation, and I will force it to use redundant constraints by grounding the flexible subassembly, constraining top-level components, and constraining components within the flexible subassembly. So now I will. You may wonder where I am getting to, but please follow me. I will get it. I will get you there when you will be surprised. So grounded flexible subassembly container, constrained top-level components, constrained components in the flexible subassembly. So now we will have a situation when constrained subassembly components will redundant the grounded state of the subassembly, and potentially these two are in conflict because when the assembly is grounded, there is likely to be a conflict between the constraints and the grounded flexible subassembly. So generally this is not the case that we should follow, but we are now following it in some purpose. And just a quick remark, you may wonder why to constrain the components afterwards when the subassembly is grounded. So I will need it later in the attempt number 4. Now let's stick to having constrained the top level, the flexible component. The problem is now I want to apply this constraint between these elements and the assembly itself. If I just unsuppress the constraint this moment, I will get myself into trouble because I will get instant conflict with the existing grounded state of the flexible subassembly container. But this is the over constraint situation. I will do that to show you this is how this works. So now I will just show you what will happen. This is the x-axis of the flexible subassembly component, and as we can now see, the axis is here. So it okay. Generally, I will undo that. Okay, I know it will not bring us a problem here. I will just make it unground, and I will just make it slightly moved. I will ground it now. Probably it wouldn't move. But generally, this may cause a problem. If I unsuppress that, unsuppress that, and unsuppress that, I have these components fully constrained within their assembly. Now, I can have, I am not having that because this assembly was grounded in the position according to those. But if I unground that, and I will now, let's say I will undo that, then I should be free to move this assembly in this direction. Okay, where is the okay, so now we have a situation when we cause the problem. This assembly is grounded. Okay, so this assembly is grounded. The YZ origin plane is here, while in the subassembly we will activate the YZ flash constraint with the threaded axle. So I will unsuppress that, and now I will get a error, because this is the over constraint situation when the grounded status of this subassembly is conflicting with this position of this element. So I will now unground that. I will go through the ridiculous pseudo edit of the flexible component just to solve, we already know this is a bug. Maybe it will be fixed. Sorry, just there. And now, okay, now I do not have any indication of failure, so I will now ground it. And this moment when I apply grounded constraint to the flexible container assembly, I am having over constraint situation when I have these elements constrained twice, once by the constraint of the top level twice by acting together grounded state of this assembly container and the constraint within the assembly container. So it is over constraint. I will now try if it is possible to drive. So we see that it is not possible. So this also doesn't work, as it should not work, because it is over constraint. Although these are redundant constraints, but basically this is more or less as expected. Now I advise you to follow me to attempt number 4, when I will ground the flexible subassembly. So as it is now, I will ground top level components, so this will be a change, and I will constrain the components within the flexible subassembly. So this is basically as it is now. The components in the subassembly are constrained to the subassembly. The assembly is grounded on the top level. Only one difference is I will ground the top level components in the top level assembly. This will make overall over constraint and redundant constraint situation. So please follow me. So I will now ground that. Now I have, first I have redundant constraints between grounded state of that and those constraints here. I will temporarily reduce this by suppressing them. Okay, but the importance is that this has a grounded state, so there is no way, if I am to use the grounded state of this component, I have no way of constraining this component to something else in the assembly. So, and now let's check if we can drive this constraint. And a miracle just happened, because this constraint is now drivable. If we go here, sorry, if we go here, we also see that the indicator is moving according to the thread pitch. I will just maybe put minus there. So we can see that the assembly in this over constraint state is now being solved in a stable way, as the constraint solver is capable of solving the assembly in any position. So this is very, I will just make it a little more, let's say 50, and we just increase that. So as we can see here, it is working now. It is working properly. It is being solved stable. Only required for that is a very particular usage of grounded state of elements plus having redundant constraints. Because if I now you may ask me, yeah, let's why don't you remove the redundant constraints? Okay, let's remove the redundant constraints. So the redundant constraints are now this moment we have some problem because there is not the inventor is not responding. I suspect a crash here. Let's see, maybe it will work. This I didn't expect, so I will give you a splash screen. Okay, we have. Okay, so it resumed. So I will remove the redundant constraints. Suppress. So now we have a situation without a redundancy because the flexible subassembly container is grounded, this element is grounded, and elements in the flexible subassembly that are free to fly inside are constrained on the top level. Is the angle constraint drivable now? Let's see. Well, it is not. As you can observe clearly, this is not working. To have this assembly solved properly, for some paradoxical reason, we need redundant constraints. And we need those free redundant constraints. Now, when I have those redundant constraints and over-constrained assembly built badly plus requirement for this element to be grounded, I can drive it. And it is working. It is working, although it should not. So we have a situation when I will let it play. So we have a situation where in the badly constrained assembly we have a stable solution. Plus we have a requirement for grounding. Without grounding this component, this is not working. So we have to ground the component that the flexible subassembly is constrained to. Then we need to ground the flexible subassembly. Then we need to define redundant constraints within the subassembly, and then we can have flexible subassembly being solved. This is not really an option because in the real world we cannot expect for this element to be grounded because it can be constrained to other parts in the top level assembly. It can be then it can then move. Also, when we place a flexible subcomponent, it is often the case that the flexible subcomponent connects two elements on the top level assembly. Like for a jack, for example, if we place a jack is connecting two elements and it is pushing one against the other. If we would have to have both of the elements on the ends of the jack grounded, then this will not work. So this is not the solution. There is a bug in data preparation for the constraint solver, I believe, because for a assembly with a flexible subcomponent to be solved stable, it is required for those elements to be grounded, and this will not work in the real world. Can you please examine that and find this problem where it is and make it work? Because it is working, only it requires some explicit limitations that are not usable in the real life. So please, can you refer to this video? Can you refer to this data set I have provided? Can you refer to the 4 attempts that I showed you? Everything you have here, please take that, and I very appreciate if you contact me, and I am open to work with you and finally have it fixed.